for example, YouTube would do it was it would have not only your data in one location, but it would have the entirety of your data in multiple locations around the world to have it cached, right? And so they use way more data than they should per video, but they do it because it's a service that really needs like streaming access immediately.
So that's the whole idea why we are encrypting the file with your own private key in your device. So that means when the file is transferred to us, it's already encrypted with your private key, and you need your private key to open that file. So for storage, all of them, majority of them follow the S3 standard, which is the Amazon S3 standard. That's what it is. So our system is compliant to S3 standard. So you just need to change those pointers, and you can really migrate your data easily.
Create a warm and engaging introduction for your podcast. Consider Great Tone as a suggestion that combines an upbeat and inviting spirit without any background music. Welcome to Tangelic Talks, your go-to podcast from Tangelic, where we dive into the vibrant world of clean energy, development, sustainability, and climate change in Africa. We bring you inspiring stories, insightful discussions, and groundbreaking innovations from the continent making waves in the global community. Tune in and join the conversation toward a brighter, greener future. Let's get started.
Welcome to Tangelic Talks, a podcast at the intersection of energy, equity, and empowerment with your co-hosts Victoria Cornelio and Andres Tamez. In today's episode, we are diving into one of the most invisible but rapidly growing climate challenges of the digital age, data. Every search, every AI model, every cloud upload lives somewhere physically, and increasingly, those massive centralized data centers are consuming enormous amounts of energy and resources. So our guest today, Murphy John from StorX Network, a platform exploring how decentralized storage could reshape the future of digital infrastructure, is going to help us understand a bit more about digital autonomy, resilience, and the environmental cost of the internet itself. Welcome, Murphy.
Hey, thanks for having me. Really excited to be a part of the podcast.
No, this is great. Honestly, we keep talking about this season, and I think we really needed to nail down this conversation because the internet feels invisible many times. You know, every drive feels like it's in the ether, and we don't really take into account how that's happening. Where is it? You know? So, most people don't think about the environmental footprint of data. Can you give us a bit of an idea of how big of an issue these centralized data centers are?
Yes, actually, I'll start with background. So first, let me talk about the data that we're generating, and then we get onto the storage of it. So if you see the kind of amount of data that we've been generating over the period of the years, like it has been enormous. So just some statistics: the amount of data that we generated over the past 5 years is far more than the data that we have generated in the past 20 years or 30 years put together. That means we are generating a humongous amount of data, and this data needs to be sourced somewhere or the other. Now, what's really driving this data? Because there are a lot of IoT devices, smart devices all over the world, driving smart cars coming in, and a lot of autonomous software. And of course, AI is one of the very big things that plays a very key role in this. So what happens is, as soon as you start generating so much amount of data, you need a location to store it, and you need to store it very securely. And the reason why I'm talking about data is we really have this feeling that we are living in the data economy right now. So data has become really very crucial for every organization. And with so much of data being generated, so much of the output is generated, I think it's a very critical and a very crucial factor in our life. So what happens is this data actually, everybody has, if you talk to a non-tech person, he'll say that data is on the cloud. He doesn't know where it is. So there's nothing.
Yeah, it's in the ether.
Yes. So it ends up on one of the physical machines, which is located somewhere at some location. And that's what is the driving challenge that we have today, because this all data is actually residing in some data centers. And these data centers are one of the highest consumers of electricity and all the other resources put together. And if you see just the data center is almost like consuming, not only consuming huge amount of electricity, water, and all those resources around, but they are also underperforming. So that means if you do an access, or if you do an audit of all the data centers, they are all being underutilized. So if there is a huge data center that is being set up, it's actually underutilized. So that's where the huge issue comes up, because they cannot scale up to the full level, and there's a huge amount of electricity and all these resources that's being wasted. So most of them, but you see, there is a demand which is growing, and there's this data centers which are lying idle. So when we talk about data centers, we always talk about these hyperscalers like Amazon, Google, Microsoft, all of these guys who are spread. But there are multiple data centers, multiple service providers spread worldwide. So what happens is we are in the mission. So we found that this data is something that is very critical, and this data center is consuming so much of electricity, wasting so much of electricity because of the underutilization. So we kind of tend to bring this things together. So what we do is we utilize storage which is located in this such underutilized IDCs, and then we store the data there. So we're not setting any greenfield data centers. We're not setting up any additional data centers, any resources. What we do is we have a community member. So we have a community of storage node operators who are spread worldwide. So we have like in multiple geography, multiple locations. They go and source these data centers which are underutilized, and they bring in the resources to us where we store this data. So instead of we storing your data in a single location, we split your data and spread it across to them. And because we're doing it this kind of, what helps actually, the other additional advantage of using us as a data center, because we're not storing everything together in a single location, which was traditionally how the data is being stored over so many years. If you go to any hyperscalers, they just take your file and store it in one single location. But what we do is we break your file. First, we encrypt your file. We break it into multiple pieces, and then we just store those encrypted fragments across multiple locations. So what happens is I'm spreading out my data. I'm like decreasing the risk which is associated with single file of storage, and then as well as utilizing the storage which is located, or the data center which is underutilized. So that's how the economy goes around.
Yeah, that's really, really cool. So you're maximizing the usage of data centers that already exist, so that we're not wasting resources. When you say that are the files themselves being split and encrypted so that you
Yes.
basically don't have? That's super cool. So it's going to be very hard for someone to get access to that data and to use it maliciously. And if they get access to one data center, then they don't have access to the data anyway, right? They have to get access to the whole thing and then decrypt it. That's super interesting. Now, can you tell us a little bit more about, before I can start asking questions about your product? Like, is this an enterprise product? Is this a consumer product? Like, what type of data do you guys store mostly?
So we have both. We have offerings which is there for B2C customers. So the end users can just come on, log into the website, register. We have a 2 GB free for life plan. So they can just register, sign up and started use. They don't have to part with credit cards or anything like that. So you can just sign up and start using it. So that's the B2C configuration. And we have a B2B setup where we work with enterprises around the world. So who is looking at storage use cases, they have multiple use cases requirement. We work with them, we design systems around them, and then we give this system design for them. So we operate on both the scales, B2B as well as B2C.
So one of the issues that I can see with that is latency, right? To access your data if it's being split among multiple locations. In fact, one of the ways that, like you say, the hyperscalers deal with this. Now, you guys don't have to do this, but the way, for example, YouTube would do it was it would have not only your data in one location, but it would have the entirety of your data in multiple locations around the world to have it cached, right? And so they use way more data than they should per video, but they do it because it's a service that really needs like streaming access immediately. So do you guys, is it like it's okay to sacrifice just a little latency because it's not a streaming platform, right? You just need access to your data. Or do you guys have ways to mitigate that?
Yeah. So the other guys, the hyperscalers, what they do is YouTube is a good example. They have locations which are at multiple locations, multiple geographic, and then they have peerings with their ISP that ensures that this kind of latency is not there, because specifically they're working with videos, and streaming is like the main. So people don't want to wait when they're looking for some streams. For us, it's like business data. So what the advantage that we're working on, or the best advantage that we have is, because we are spread out across multiple geographies, we can offer them very high level of reliability and resiliency for the data. So it's not like just one location, one thing, and the algorithm is designed in such a way that it will always look at the nodes which are really available. So what one thing that we do is, I will just come back to the way how we do the entire engineering around the product. So whenever you're using StorX to secure your data, so what we do is in the user's laptop or device itself, we will encrypt the data with their own private key. So that means it's encrypted at user's device only. And then the encrypted file goes to the server where it's broken down into multiple fragments. Then we replicate those fragments and then we distribute it. So actually what we do is your file, when we are dividing it into fragments, we create multiple copies. And these multiple copies are located at different geographies. So suppose there is a file, you have like 1, 2, 3, 4, 5. One file would again be divided, replicated 3 times or 4 times, depending upon what is the nature of the file. And this would be residing in 3 different geographic locations. So whenever you're requesting a file, the system will know where the file is, and then it will know which is the nearest location from where you can get this file. So I won't go to the remotest location to get this file. My system will know that this is located. Suppose you are in Berlin and you have a location in Frankfurt. That means that the file, you can fetch the file very fast. So it will go to the Frankfurt location, get that fetch. So that's how it operates in the engineering.
Okay, so you guys do have it set up so that there are multiple copies of it, but you guys mitigate the environmental impact by, like you say, using data centers that already exist that are underutilized, right?
Yes.
Okay. There's a difference between data centers, right? Like there's storage data centers and then there are compute data centers.
Yes.
What is the difference in the environmental impact, right, between something like a storage data center and a compute one? Like in how much cooling they need, how much power they consume. Because I think that's important to know, right? Like not all data centers are the same.
Yeah. So because the compute is more intensive, it requires more energy and more efficiency to operate. Of course, because of the new kind of development that is coming in because of quant and all those kind of development, you see this consumption coming up. But if you compare storage with computing, I think the compute part would be much more energy intensive, and it would be utilizing more resources compared to the storage, because storage is just dumb storage. You don't do processing around it. So, and in computing is actually processing a lot of data.
Yeah, that makes sense, right? They still need to. There's still a lot of heat that needs to be managed and stuff like that, right? So you need a lot of cooling and such. So that would be a lot of the cooling capacity. I think is the big one for data storage.
Yes, so that's really a big amount of HVAC that's required, cooling.
Where do you like see the industry going? Do you see it going in the direction that, data is really interesting because there are multiple facets of the morality to it, right? You have the server itself, which generates heat, it consumes a lot of energy, and then you have the aspect of the data itself. For example, you guys, I imagine you said you deal a lot with enterprise B2B clients and stuff like that, right? And also consumers. But is your model sort of a privacy first instead of we have cheap prices, but we're going to use your data for however we want right now in this data economy where everybody wants people to stop abusing their data and using it for everything? Like, is it one of those cases where like one of the edges that you guys have not only is the environmental thing, but like the idea that you have access to your data, we only store it, we don't look at it, we don't sell it, we don't do that? How does that work?
So privacy first is the most important characteristic of our project. So what we do is whenever we are so that's the whole idea why we are encrypting the file with your own private key in your device. So that means when the file is transferred to us, it's already encrypted with your private key, and you need your private key to open that file. So that's the idea, and we are like privacy first, security is the second part, third is the reliability and resiliency. That's how we have categorized it. So the outmost benefit that we offer is privacy and security of your data. Nobody in the entire ecosystem that StorX offer can ever snoop into your data or look at your data or see what's exactly residing in the data, because it's always a fragment that is always lying in one single computer. Nobody else except the system knows where the multiple files are. Even if those multiple files are accessed, you still need that private key which is lying on the user's desktop. We don't keep any private keys, or we don't keep any encryption keys with us. So it's ultimately the user who controls the data, and we don't do any kind of snooping or any processing. By the way, we are an open source project, so we like the entire source code of the project is available on GitHub. People can just go and see the kind of processing that we do for data. So that's one.
So a power user is like, I want to verify that they're telling the truth about how the project works. They can just go to the source data and be like,
yes, and it's been audited 2 times, and we have the audit results also placed on the site. So it's like open for everyone to just go and visit and see what's the results.
That's fantastic.
That's awesome, because that's one of the things. These are very complicated topics, and the lack of transparency just makes them even harder to engage with, doesn't it? Why should a normal person, ordinary person, care about who controls the data infrastructure? Because you've probably heard the jokes of like, oh, I don't care if X is, looking at me. I don't have anything. I don't have any secrets. I don't care. Why should we care?
So when the cloud revolution started 20 years back, that's when the hyperscalers started moving. So before hyperscalers, it was all like on-premises. And when the hyperscalers came into the market, the 3 big hyperscalers, they promised 3 things that would be there entirely that the cloud would provide. So that seems to be the pillar of the promise why people moved from on-premises to the cloud. So those 3 were like they would offer high level of security and privacy. There would be less cost compared to hosting it in your on-premises. And the third was unlimited scalability. So when they were hosting data in their specific location or on-premises, you always have a capping. Like if you want to raise your storage capacity and compute capacity, you need to do a lot of capex and you need to bring in servers. But when you're keeping it in IDC, that was like very easy. You can just by the click of mouse, you can just upgrade your thing. So the 3 promises, out of the 3 promises now, there's only scalability that remains. So the other 2 was compromised over the period of time. You know what happened with Cambridge Analytica? There was there's so many abuses around that. So it's already in public. So I don't want to comment on that. The prices also have been steadily rising. If you see the cloud prices, what it was promised, now you see people end up like if you talk about a typical SaaS software organization, they have like 10 to 20% minimum, and sometimes it goes up to 30 to 40% of the cost. The entire cost is the computing cost or the hyperscaler cost that you give. So that will become a very huge cost that has become right now, and that's really something which is really concerning. About your question of privacy, it's in fact growing because of all these abuses that has happened, and then there is some inevitable threats to the data because you are storing your data in a public cloud. That means it's not a private location. It's like open. You have the same kind of infrastructure. You have the same kind of accessibility. A hacker can come in and access any one device and he can get into the entire system easily because those architects, everything remains the same across all the network. So what happened was that's a funny question that we get. In fact, the point that you raised, like I'm an SME, why should I be concerned about storing my data so privately? I don't know, nobody's going to be behind me. But they need to understand, like if there is a ransomware infection that happens, if there is a virus attack that happens, it generally happens with the loophole that is there in the system. They're not interested in specific things, so they'll lock in everything, irrespective of the fact whether you are an SME, you're a medium size, or you're a big multi-billion-dollar organization. It doesn't matter. They will just come and lock everything. So you need to be really very secure, and you need to take that consideration into practice. And of course, because of so many of laws which are enacted everywhere, because of the safety of users, you really need to know where you're kind of storing your data and how secure your data is. And I see that is growing among the people right now. It was not such a big concept or such a big threat 10 years back, but now definitely people are looking in like where my data is stored, how secure is my data, how many people can access my data. It's really a concern right now.
And in the era of AI, also, how is my data used, right? Like, is it like if you upload it, for example, to a competitor, I'm not going to name any specific competitor, but they're like, okay, from now on, we're going to for this month we're not raising prices, but like all of the stuff on your cloud is going to be used to train AI. It's like, well,
So they don't announce it publicly, but everybody knows that happens. So that's very beautiful. Like we work with certain organization, those who are having a lot of proprietary data, like years of organizational data and all the data related to their finance and everything. They were very concerned about putting this data in the public cloud and training the LLM. So they came to us and they said that we want a private cloud which is not accessible any third person, and we will you set up the infrastructure for us and we will run our LLMs on top of that, just to ensure that our LLMs are accessing our data and there's no third party who's accessing data at any point of time. So that's where the privacy, the security of the data is really very concerning for people who are of this age right now.
Yeah, that makes sense. Not kind of having it out there for easy access. I guess from a financial perspective, why are centralized systems still dominating then? Because this sounds like the obvious next step, but I don't think there's been a move to that as high or as rapid as one would expect from such a great proposal.
So what happened is now, as I told, the hyperscalers have been in the market for past 20 years. They are building systems. Of course, they have done one of the best things that is, I think, the growth of cloud is really responsible for the growth of a lot of industry around it. Like the SaaS business only evolved because there were so many hyperscalers, and they built in a lot of moat around the product. So there's a lot of facilities, lot of good things that was built around storage and compute, which were able to, which the end users were able to utilize and build systems on top of that. So that's how they've been growing, and that's how they'll grow in the future also. So that's because of the enormous benefits that they offer this thing. And one thing is, nobody is thrown out of the job if they start hosting in any of the hyperscalers. So people are like, that mindset is created over 20 years of time, that they're very secure. Yeah. Of their very scalable sort of thing. That notion would still be there for a long time, but there'll only be, I see that decentralized cloud is going to create its own niche because of the advantage that it offers.
Of course, yeah. And something I've heard a lot of times is the migration from one system to another tends to be quite the headache, especially internally in a company. So how hard is it to convince businesses to adopt a new infrastructure model like this one specifically?
Okay, so I'll talk about the storage part of it, the two components, as you know, this compute and the storage. So we work only specific storage, we're not doing compute. So for storage, all of them, majority of them follow the S3 standard, which is the Amazon S3 standard. That's what it is. So our system is compliant to S3 standard. So you just need to change those pointers and you can really migrate your data easily. So that was something that we really worked from day one. We knew that if we want to have systems built in that is easily accessible, we need to go in for a global standard. So we have built into the system right from day one. Because we have adopted those standards, it becomes really easy for anybody to migrate the data and use our systems.
That's cool. And from a consumer justice perspective, so, the people themselves, do you think decentralized infrastructures kind of help make digital access more equitable globally, or is it kind of separate and a happy coincidence if it does?
It would be both actually, because of the, as I told you, they took 20 years to come into this stage. If we would have been pre-hyperscaler age, where everything was on premises and people, it would have been very difficult for the growth of this whole ecosystem which was developed around. So that is useful, and they have done some phenomenal work. But as I said, there are many disadvantages because of the scaling as well, because of the ransomware access because it's a centralized infrastructure. It's easy for everyone to just attack in. Everyone can get access because it's all standardized. You just need to access one location and you can get access to a lot of locations because of the same architecture, same design and thing. So that's how the decentralized system comes as a separate entity where we can have niche built around that products, where we can scale, because the kind of scalability that we offer and the security that we offer, it's very difficult for them to do that at the same way, because we use blockchain nodes and all those kind of things. So it's a complex architecture. It's like a very it's like a lot of things built into engineering fit altogether. So it works in a perfect orchestra.
No, that makes sense. And I guess in the climate space, do you think decentralization is genuinely a solution in terms of energy use and water use and what we were talking about with storage centers being different to computing centers? Or is it risking shifting energy use somewhere else?
No, it's definitely so, because I told you, because the data centers is one of the highest consumers of electricity and energy all over the world. You can hear if there's a new data center set up in some town and county, they have come up with so much of opposition that they had to shift the plant altogether. There were so many instances around that. So definitely, it has a lot of, the decentralized cloud does have offer a lot of advantage, not in terms of you utilizing the underutilized IDC and saving those kind of resources, which is like goes very high, because we are saving so much of this fuels, green gas emissions and all, because we are utilizing the underutilized, and it becomes benefit for them as well, because you have an infrastructure set up and you have 20% of the infrastructure, 30% of the infrastructure just lying idle, and you need to run all those infrastructure, because you need to have the system has to operate at 100%. So if you save multiple geographies around the world and you're saving so much data centers, the effect is compounding, and it's always beneficial.
And then I would imagine that it would help keep, let's say, closer to, not obsolete, but closer to obsolete data centers alive, and not have all of the, because there's more to data centers, right? There's also, like, if something becomes a little bit more obsolete, it goes into the landfill, it belongs to something cutting edge, right? Can you tell us a little bit more about the environmental side of this, right? Like the carbon emissions and stuff like that, and how, like, is all of the efficiency gains basically from finding those underutilized data centers and working with them, or is there more that can be done to mitigate power consumption and such?
I think people, the organization can look at using decentralized cloud storage in a better way, so they can shift in some load from the centralized agency, wherever it's possible, and it helps, so we can grow our system and we can get in more IDCs which are underutilizing energies and all those things. So that will definitely help to reduce the carbon footprints around the world, and can save globally, like can save so much amount of energy for being wasted around this.
Is there a difference, for example, I actually don't know, like, is there a difference depending on what type of storage is used on the data centers, right? Like, I would imagine, like, how do these data centers operate in the modern day? Do they even use spinning disk? Do they all use a solid state? Like, how does it work? Is it a hybrid?
So it's a hybrid system right now. So there are because there's so many of the circulating hard disks, it becomes very difficult for them. But they are being phased out to SSDs, and then we have now more efficient NVMe. So those are the ones which are coming up. But even to phase this out, it would take a long time, because these developments that has happened, like the NVMe, the SSD, were just recently compared to the spinning desks which were there for so many donkey years, and now they're no more produced, but the kind of efficiency that is happening is really very good. So we feel that these would all be recycled very soon, and then we'd have more efficient, less energy consuming kind of thing. Because what happens is, when this discs, which are like cylindrical discs, they're rotating, they're generating heat and all those things, so that becomes a real concern in terms of environment effect and the carbon emissions and all those things. But when we have the solid disk, when we have this SSDs, when we have NVMEs, the heat is reduced very less, and because there's no physical rotation happening, those kind of cost can also be saved over the period of time. So in order this becomes much more efficient, this becomes smaller in size. When the device becomes smaller in size, they need lesser cooling, they need lesser land to be cooled, so they need less power. So all those factors play a lot of role in ensuring that the carbon emission goes down and the energy efficiency is increased.
Why are data centers underutilized? Is it like a pride thing? A lot of the companies want their own data centers, so they're just going to build more instead of finding deals to, like, utilize the underutilized one over here and over here and over here.
Yes. So what happens is, I'm talking about this in whenever the data center is set up, they set up over the period of like 10 years, because it's a huge investment to set up the data center. They can't set it up like just so. If there is an energy utilization that they think of like 100 racks, they would end up setting up the infrastructure would like 500 racks. That is the in standard when they set it up. So because they set it up in such a way, it's always, and what happens is when you go, suppose you have 5 floors of data centers, you have one operating at full capacity. The moment you go to 101, you will have to take one more floor, and then you will have to lighten up the entire infrastructure, because that would be big cost which is involved. So that's something that is still going on. But there are new technologies which are coming in that will ensure that they like built-in rack which is cooling, so you don't have to cool the entire floor, you just have to cool the entire rack itself. And then there are of course new things coming around oceans, and then there's space IDCs which are coming up. So all these things will really go a long way to ensure that we have those kind of energy efficiency built up in the data centers.
That's super cool. I guess I want to close out with, what are you most excited about in this future of decentralized tech? What are you most looking forward to?
I think the benefits that we are able to offer the clients because of this decentralization is really some very good benefit. And because of the carbon emissions and the global footprints of carbon that we save, we are really very excited and committed in this mission of decentralized cloud storage.
Amazing. Well, guys, you can check out the blog at tangeliclife.org/Tangelic Talks to learn more about StorX Network and Murphy John as well. Is there any closing words, guys? Anything you want to leave the audience with?
No, I think it's a great time to be alive, and we want to be we utilize what are the new technologies coming up. I think it's great to be the part of it.
I love it. Amazing. Well, we'll catch you guys on the next one. Thank you.
Let's talk power, let's talk change. From rural lights to brighter days. Equity rising, voices strong. We're building tomorrow where we all belong. Tangelic Talks, energy, equity, pride. Empowering the world, side by side. A spark becomes a fire, a vision that's true. Together we rise, it starts with you.